Hi, this is Evgeny. So when it comes to dealing with asynchronous frameworks, if you never dealt with them before, it might be confusing. And the documentation often doesn't help dealing with this confusion because there are way too many concurrency related terms. Plus, overall, it's relatively new thing, not something that's been a while since forever. So, and not everyone uses it. Uh, so sometimes it can be tricky to navigate this space altogether. And so one of the approaches that follows because of that is just writing async in front of every function and just hoping for the best. The other thing some people do is just writing stuff synchronously like they used to and ignoring this part completely. I was also asked in my previous video why I didn't use async functions for tutorial, and that's a good question. And there are actually a couple reasons for why I didn't want to do it. First, I didn't want to make the video more complicated. But today I want to talk about this topic more in depth and show how it works in FastAPI with some practice. We'll make some basic benchmarks, and I will try to explain some theory behind it the most simple as I can. So let's get to it. Here we have some endpoints, and I will quickly show you what functions they're doing and how it works overall. So here in our code we have basic FastAPI application that has those routes. There is URL list. It's just a list of websites for which it will try to connect during some network process. Then this one will run function on a separate process. We'll go to it later. And there are several types of things that we can try to do asynchronous. The first one will be emulating CPU calculations, some blocking CPU bound function. And it will also take a file and just emulate some things that it does with the file. It will flip instead of doing something heavy, some heavy computations. And this one is written with async. It doesn't use async slip because CPU bound will always be blocking like that. It won't be fair to use async here. The other one does exactly the same, but is written with regular function, with regular style, like async. Next thing we have is sending some network requests. One would be sending asynchronous one through HTTPX. It will just send a request to all those URLs that we've seen asynchronously. And the other one will be doing the same thing with async keyword, but with regular request style library. Just synchronously, normally. And then finally we have file reading. It will be also synchronous and asynchronous. We will just get the file and try to upload it to our server. Server will try to read it, and when it's finished, it will just return done, nothing else. Read file just uses regular style like you always do in Python. Asynchronous version will use library called IO files that does this stuff asynchronously, at least how it claims to. And now let's look at our functions. So, and the most important function that we have is greeting. It will just send us hello async world, and we will try to access this endpoint while running other endpoints, and we'll see if it will be blocked or if it will return at the same time. So all our endpoints are combinations of reading file plus doing something else. Since we're trying to do asynchronous and the whole point is to make several things at once, we'll try to read file asynchronously and just try to do other stuff and see what's going on. First of all, let's try that pseudo async thing. There's one more route that will try to read file synchronously, but the function itself is written with async. It's like something you might do when you don't know what to do. You will write it, hope for the best. So let's see how it will work. It will show us how long it took as well. So let's select a file. Let's select let's select a big file actually. So it will take some time to execute, and while it's executing, we'll try to read, and it returned at the same time. So you might be thinking like, well, it seems that asynchronous keyword works. You see, yeah, it's returned deployment, done, and all other stuff. So it worked fine and didn't block anything. But now let's see the regular read file synchronous that will use our synchronous function without async keyword as well, and execute it. And now let's try to greet, and it also returns right away. So I'll clear and show it also returns right away, and here it also doing the same thing. So then, does it actually make any difference if we wrote asynchronous read file or synchronous one? Because this one just uses the regular one. So what's the deal here? So before we explore what actually is going on, let's look at the other functions, like this one. So this one will read a file and then use some calculations, our CPU bound function that I showed you before, but it will be written with the async keyword. Now read file and calculate synchronously. Yeah, okay. So let's take any small file actually here, because it computates that stuff. And now look, we can't greet because it was blocked by the CPU, even though you wrote asynchronous in front of it. So it actually didn't work asynchronously. We can try it again with anything else, like, and it still doesn't return. So, okay, now let's try to do the synchronous version of the same thing that will do the very same thing, but just with without async keyword in front of it. We're still, we can't await our read data file now, so we'll just use the regular read file data and try it again. So we're CPU blocking, and we get the other one working at the same time without any problem, and it all does. And so notice the thing here, async keyword actually didn't let our application to be asynchronous. So let's see more examples of what can be achieved with the async keyword. Let's try requests. First of all, there will be a sync keyword in front of regular request get that you use as normally, and we'll use that and reading file asynchronously. So yes, this one. So again, we're choosing some file, we're executing, and we didn't get it at the same second like we did before. And now look, it took 3.5 seconds. And it also blocked our greeting. So now let's try the async version of it, the real async version, which uses HTTPX, awaits mix different tasks with the same URLs, and basically does the same thing, but truly asynchronous. Use the same. So previous function took like 4 seconds instead. Now this one took just 1 second. And it also actually didn't block the main thread. 1 second won't be enough to load both endpoints at the same time, but we'll sleep. So we'll sleep for extra 5 seconds to give us some time to check if we can still access the hello world endpoint. So we're loading it, and it returns at the same second. So it worked actually much better. It was faster and didn't block anything. So now let's see why all of those things behave the way they did and what we can do to optimize the usage of asynchronous in FastAPI. So what we must note here is that there are types of blocking. One of them is CPU bound blocking, is when your computer does some calculations and it's really busy processing something, so it can do other things. And the other thing is input-output bound blocking. Input-output bound blocking usually just awaits, it basically waits for stuff to either get through network. It also includes databases. If you connect to your SQL database, you're waiting for query to perform there. Or it can be network. You're sending you're trying to connect to some API or website. Or it can be just regular file reading and uploading. So with CPU bound blocking, Async IO, as you probably might have heard already, won't help you that much. But with IO bound blocking, this is why it's called basically Async IO, it might help you by bypassing waiting time. So if a thing is IO bound blocking, when it regularly, what it does in sequential programming, the thread fully consumes CPU, as you can see here. But if you're using some asynchronous things, functions, then it can just switch to the other thread while waiting is happening, or it can run several things at once. But the important thing here is that it actually all is happening in one process, in one thread. Let's see what happens in FastAPI behind when you are trying to run endpoints with a synchronous keyword. So we went to FastAPI and it's routing, and you see here it says run endpoint function, and it looks if what you are passing is coroutine. So basically, if you wrote that it is a wait function, then it will be true. And if it's coroutine, then it just calls it. And the important part here is if it's not coroutine, then it's run in thread pool. What the thread pool means? Well, thread pool is basically you have a process, and inside that process there are separate threads. that can do different type of stuff at the same time. I will talk about it a bit more in depth, slightly in a minute or two. But the important part here is if you wrote await, then the task won't be run in a thread pool. It will be awaited. So if you are trying to pass something that cannot be awaited or that is actually blocking and write the async function, then it will block the main event pool. It will break the main thread that is running the event loop. And that is why exactly when you write async without actually using something that is truly async deep down, you might actually be making things a lot slower than they were before. So now let me show you something that I made to demonstrate it the best I can. So let's imagine you have several tasks. If you're doing it the regular way, this will be a task and it will just be execution time. It will just finish one, then start the other, finish one, start the other, and like that until it finishes. Then there is that non-blocking, that asynchronous way. It does this, takes all the tasks. Then you use some function like async.io gather, which we're using in some of our like here when we're sending requests. So we're making several tasks that will of sending something to URL. Then we gather the task away and await them. Then it will start, it will just make it all 5 tasks in one big task basically, and then they will be able to start at the same time. So you won't be waiting each one of them to finish, and that's why it takes way less time. So it finishes. And important thing here is it should be, well, truly asynchronous. It uses event loop. What is event loop actually? Event loop is just a fancy word for while true loop, which every cycle that it runs, it asks, is it finished yet? Is it finished? Did it finish? And so forth. And when it's finished, it sends it tells the executor that the some task was finished. If you, it only creates the illusion of concurrency, as I wrote here, because actually there is no there isn't many threads, there isn't many processes. So imagine like this block that we have here is one thread in one process, and this one just runs event loop, and because of that it might bypass some waiting. So you will be basically just waiting for stuff at the same time instead of one after another. So the advantage is where it's pretty simple to use if you know what you're doing, and it's less error prone than threading, which I'll talk about next. Minus is that you need to kind of know what you're doing, because as I showed, the writing async in front of it just doesn't cut it. So you need to use asynchronous libraries and functions, and sure, it won't help you with CPU bound tasks because they will still block, doesn't matter how you write them. Then there is multi-threading. So what is the multi-threading? Well, basically, imagine that this green block is a process. It's virtual or real, like you have 2 cores on your CPU and 4 threads. And imagine that this is one of those 4 virtual cores or 2 cores that you have. It all connect. This will be the memory of that CPU, and you might run several threads on it that will all execute each own thing, but they will all use the same memory that your CPU uses. So they share a memory within a process. One of them can be asynchronous, like in our case. So, and what we saw FastAPI does is that it asks for endpoints to, if they are not, if the function is not asynchronous, then they are run in a separate thread. That's why you can actually have like 10 incoming synchronous requests at the same time, because just each one of them will go to a different thread. So it will be actually asynchronous, even though you just set the regular synchronous endpoint. Because FastAPI does it under the hood. It does the asynchronous stuff using threads. Now, why we don't use threads all the time for everything? It makes it much more. It makes programming more tricky and complicated. Because it can cause deadlocks and race conditions. So several threads might try to change the same values, and then God knows what happens. And it will be very hard to debug and understand what happened in the end. Then there is Python global interpreter lock. Then switching between threads also takes some time and some power, and in some cases it might make it even slightly some tasks slightly longer, take slightly longer, but overall it sure will be more efficient if you need to have to process several input bound stuff at the same time. And it also doesn't help us with CPU bound tasks, as I just like previous things that we looked at. And the advantages is, well, it shares memory. So if like usually your functions needs to use the same kind of data, then every thread can access the same data. And each process can span many threads to run different tasks. But and it's also something when you set up GUnicorn web server, for example, you usually specify on a server in production how many threads you need for it. Usually it recommends something like 2 times the amount of CPU cores plus 1. And spanning and since threads also take up memory, spanning too many threads might actually slow down your computer quite a bit. So it's not recommended to create too many threads. It's something that you need to have resources for. And next, we're going to just multiprocessing. So this is like those same like in multi-threading. I told you that this is a process in which those are the threads that I show you here, and those will just be separate cores, let's say, of your CPU, which each has its own cache, its own memory access. It is restricted by physical processor cores, so you can't have more than you actually have CPUs. But the advantage here is that it finally allows us to run multiple CPU-bound tasks concurrently. So at the same time, you can calculate 3 times faster if you do multiprocess. And it doesn't share memory, but which makes it, well, harder to use for tasks that are tightly coupled. So those are basically the types of concurrency that we have. I tried to illustrate it the best I could. I hope these things that I drew make it easier to understand, because when you're just reading those threads, course, multi this, multi that, async, it just all turns into one big porridge in your brain, and you don't remember which one is which anymore in the end. So, and now let's get to what we should actually do. At least what I understand you must do when using concurrency and asynchronous programming in FastAPI, for example. So first of all, file reading. If you use it synchronously like regular, it will go to thread, so it won't block. If you use it asynchronously with the IO files, which is async library, it also goes to thread, because that's what the IO files does underneath. If you look at the source code, it just does the same thing that FastAPI is doing for you when you're writing the regular stuff. It just does it implicitly, so it actually doesn't matter at all which one you use. And the weird part is that even if you write async here, it also doesn't block, as I showed you. So here I didn't see much difference at all in terms of async. It just goes to thread either way. So file reading is that way. Then we go to the quests and networking. Well, if you are using something that is supports synchronous, requests regular library that most people use, it doesn't support async keyword. So if you're using regular one, just use it regularly. Don't write async in front of it. You'll just block the main thread. And that's overall something that can be said about all the libraries. If it's not a synchronous library, don't write async in front of it. If you don't know if it is, just don't write async in front of it, because otherwise you will make it slower, because you will block the event thread of the FastAPI, because it wants if you write it with a regular way, it will send it to thread, so it will actually be asynchronous without writing async. So that's where some confusion might stem from if you don't know what you are doing. So and the best thing is sure to use async with and gather tasks like here. So first, because if you just await each task one after another and don't use the async IO gather like here, it will still be like regular. It will just do one after another. Only if you're gathering tasks, then like I showed here, it will do all the stuff concurrently, which is what we want. So overall, use something that supports async, either HTTPX or IO HTTP or something like that it's called. So if you don't, then use regular without async here. So like that. And then the databases. What about databases? In my previous video where I showed tutorial of how to do, I didn't use any async databases. It was regular database. So there is no point in writing async in front of every endpoint or function that uses database that doesn't support async, as we know already. And the thing is, if you don't need if your application isn't something that needs to be accessed by like a lot of people, like thousands of people a minute or a second or an hour at least, then the chances are it will just be easier to use regular databases and write it the regular synchronous way, because probably the regular workers will do just fine with it. If you need a high load application, then use asynchronous databases for it. You can't use the regular wrappers like SQLite or PsychoPG. Instead, you need to use the special ones. And I wrote here some async libraries. So request is IO HTTP and HTTPX. PsychoPG is async PG. There is a library like that. Then if you want SQL Alchemy support, but only the core part of the library, so if you're using ORM with your database, then there is a library called just database. Just Google it, you will see it. If you're using Redis, then there is IO Redis for it. So don't just write async in front of synchronous regular libraries and wait for magic to happen because you heard that FastAPI is asynchronous. You actually need to use asynchronous capable libraries with it as well, or just don't use async word at all. So next thing we're going for is calculations. So what you do about calculations? I also I actually wrote it down here. So first of all, if you can cache computations, then you just should do that. Maybe if it's inefficient, you may be just redoing the same thing over and over, and then it doesn't make sense, and caching can actually reduce workload quite a bit. Then if you're using just some regular small computations, it's calculating something like for 1/4 of a second, then just use regular synchronous stuff. You don't need it. Then if it's light something that is blocking for maybe a couple of seconds or so, then it's best to use background tasks for it. So let me show you what background tasks is. Something that we also import from FastAPI. And let's see the our endpoint which uses tasks. So we import it as a dependency injection for our function. And here we use background tasks, add task, and what we're trying to do. So here we're trying to calculate data for file synchronous, that one that takes 6 seconds and blocks the thread regularly. And here we were also waiting for our async read file data. So let's try to do that and see if it blocks the thread like it regularly did when we didn't use async text. So read file and calculate synchronous. So again, we're sending this. It returned right away. Okay. It returned right away. That's the thing, by the way, that you want, if you don't need return data, then you can use it because, but this calculation is actually still happening, but it's happening in the background. So you can't actually return something right away. So if you write the result to, let's say, database or to some file or to something, but don't need to send it back right away, then use background tasks. So if you, as you see, the cool thing is it just returned super fast right away. Now let's try to upload the bigger document so it doesn't return right away and see if it's blocking. Now grid returned right away even when this is still loading. So and the other one went to the calculating. So it doesn't block main thread and it also returns instantly. So it's a good thing to do when you have a CPU bound task which doesn't need to return right away. So that's pretty cool. Other thing that you can do is to just send it to explicitly to a separate process and to send your task which is CPU bound. And here I'm trying to do that. So I made a function called run in process, and it gets event loop of async IO, and then it awaits it running in executor like that. So let's see. So I'm creating again tasks that I'm gathering later. I'm reading file data, and I'm trying to run this process with its arguments in the same thread and pass into tasks. Now, read file and calculate synchronously. It's also a pretty cool thing. Now look, let's say I am importing this thing. So it doesn't block the main thread because you see it returned right away here, which is good because regularly if you just write the CPU bound thing, it blocks the main thread. So it didn't return right away like background tasks did, but it returned us the result after it was done. So it says it took 6 seconds, which was our CPU bound task, how much it took. And we got return, we got our async function, and it just was doing it in a separate process. So it's also a cool thing that might be handy when you have some average size, not very heavy computations that you still need to return them, but don't want to block main thread with. So yes, and in the end, what you can do if you have what you must do if you have some large CPU bound tasks that take maybe dozens of seconds. Sure, you can't allow it to block your whole application because it just won't be able to do anything. So for any heavy computations, just also don't use background tasks because it's kind of not a good way. So the industry standard is to just run it in a separate worker and usually use Celery and Redis or RabbitMQ with it for that kind of stuff. So yeah, use that. Okay, so here will be a quick recap. I know the video was actually 40 minutes long and not everyone has that kind of time, but I tried my best to not waste your time and explain why exactly some things are the way they are, so that you get some sense in how it works overall later. So if you have time, watch the whole video if you skipped the previous part. Okay, so let's sum this up. If you have async functions, use async library. If you're using async functions, gather tasks so they run concurrently. If you have computations, run it in separate process or use a worker for it, or run them as a background if you don't need a return right away or at all, rather. If you need to read file data or something, you can just read it regularly. It will send it to thread. Don't write async in front of stuff that isn't actually async. What else? One other thing I can just mention is actually when you read in file data. Here I'm just doing file read, but read it in chunks, because if I'm sending, let's say, 2 GB file, in the end it will take 2 GB of my memory, and memory isn't endless. So maybe someone even will send a 14 GB file, and maybe you don't even have that much memory, then it will just fail in the end. So read it in chunks, like small. It just makes more sense to read it like as 1 MB or 8 MB chunks. It might actually take slightly longer, but it's just much better to do it this way. So what else we got? Database. If you don't need a very high load stuff. Just use regular database and without async, it just will be easier and it won't make much difference to you anyway. So concurrency can be a little tricky, as you see. And it is also kind of tricky for me, and I've been also struggling to understand all the concepts myself because everything is so just confusing about it, and most resources don't help, and also there are a lot of kind of just bad videos with those bad practices, like using synchronous stuff with async keywords, something like that. We see why it's a bad idea now. So yeah, I hope this video was helpful for you. And leave a comments if you have any questions or if you have any input on the subject yourself. Maybe you know some other things that I didn't mention. Or maybe you want me to talk about some other topic that I can explore in the future videos. So thank you for watching.